This video is on solving literal equations. A literal equation is an equation that contains two or more variables. It's sometimes helpful to have an equation with more than one variable to be solved for one of the variables in terms of the other. For example, the equation 3x plus 2y equals 16 can be written as x equals negative 2y plus 16 all divided by 3. This second equation, this equation right here, is solved for x in terms of y. So I can figure out what x is based on what y is. To solve for a specific variable, we're going to use the order of operations in reverse to isolate the desired variable. We did this when we were solving equations, but we only had an x. Now we can have other variables in there, but we need to focus on which one we want to get by itself. Remember that we're going to undo in reverse order anything that was done to the variable that we're trying to solve for. So let's take a look at an example here. Here's how I did this equation. For the equation 3x plus 2y equals 16, notice that x is being multiplied by 3, then it's having 2y added to it. So if I want to solve for x, that is get x all by itself, I'm going to undo each of those backwards. So since adding 2y was second, I'm going to subtract 2y on both sides. Then I'm going to undo multiplying by 3 by dividing everything by 3. Let's take a look at a couple examples here. First one says solve 3n plus 6p equals 15 for n. What that means is I want my final answer to be n equals something. I'm trying to get n all by itself. Well, let's notice what's happening to n. N is being multiplied by 3, then it's having this expression 6p added to it. So what I'd like to do is subtract 6p on both sides. So positive 6p minus 6p gives me a 0, so I'm left with 3n equals 15 minus 6p. Remember, you cannot combine those because those are not like terms. 15 doesn't have a p, so I can't make that like a 9p or anything like that. So I'm very close. Remember, I'm trying to get n by itself. N is being multiplied by 3, so I want to divide both sides by 3. 3 divided by 3 is 1. So I have that n is equal to 15 minus 6p over 3. But I'm looking at that and seeing that each one of those numbers can be divided by 3. So I'm going to simplify this a little bit. I can write the numerator as each of those terms over 3. So I can write this as 15 over 3 minus 6p over 3. Okay, just kind of undoing that subtraction. 15 over 3 is 5, and 6p over 3, I can do some canceling there, is going to give me a negative 2p. So my final answer is n equals 5 minus 2p. Okay, now you're going to get some funny looking answers, but that's okay. So what we did there was we took our original equation and we solved it for n in terms of p. Let's take a look at our last example here. I have k minus 2 all over 5 is equal to 11j, and I need to solve that for k. So I need to get k by itself. So what's happening to k? K is having 2 subtracted from it, and then the whole thing is being divided by 5. So I'm going to rewrite that down here to give myself a little more room. So I want to undo that backwards. So I want to undo dividing by 5 by multiplying both sides by 5. So 5 over 5 is going to give me a 1. That's going to leave me with k minus 2 equals, now this is multiplication, so I can go ahead and do that. So 11j times 5 is 55j. And now remember, I'm getting k by itself, so I can add 2 to both sides. And that's going to give me k equals 55j plus 2. And 55j and 2 are not like terms, so I can't combine those. I can't come up with a 57j. So my final answer is k equals 55j plus 2. So I've taken my original equation and solved it for k in terms of j. So in this video, we took a look at how to solve a literal equation, which is basically taking an equation that has more than one variable in it and solving it for one of those variables.